For this example, we're looking at e to the x sine x, and we're going to construct a Taylor series or a Maclaurin series at c equals 0. So again, we need to generate the derivatives and then evaluate the derivatives at the center, which is 0. In this case, the derivatives are going to be a little bit more involved. So our first term is fairly straightforward. It's going to be e to the x sine x, and evaluate it at 0. Since sine is 0 at 0, our first coefficient is going to be 0. Our next derivative is going to be using the product rule. So we're going to end up with e to the x sine x plus e to the x cosine x. I'm going to factor that out. E to the x sine x plus e plus cos x. So this is going to be e to the x sine x plus cos x, and evaluate it at 0. Well, sine is 0, cosine is 1. E to the 0 is 1, so we're going to end up with 1. So this ends up being 1 over 1 factorial, which is just 1. So the next derivative, we're going to again need to apply the product rule. So f double prime of x. This is going to be e to the x sine x plus cos x plus e to the x, and this is going to be cos x minus sine x. Okay, so we can cancel out some terms here. So the sine x is going to cancel out. So we're going to end up with e to the x, and we have 2 cosine x's. So I'm going to write this as 2 cosine x. Okay, so we get 2e to the x cosine of x. Evaluated at 0, where cosine is equal to 1, so we're going to end up with 2, and this becomes 2 over 2 factorial. And that becomes 1. Okay, and then differentiating this again, this is now into our third derivative, so f3 of x, 2 e to the x cos x minus e to the x sine x. Okay, simplifying this out, I'm going to end up with 2 e to the x cosine x minus sine x. Okay, so this is a little bit tight to fit in here. 2 e to the x cosine x minus sine x. Okay, when I plug in 0 into that expression, I'm going to end up with 2. And so I'm going to end up with 2 over 3 factorial. This is equal to 1 over 3. And then differentiating again, these derivatives, the nice thing is these derivatives don't get too complicated. So the fourth derivative is going to be 2e to the x cos x minus sine x, and then plus 2e to the x negative sine x minus cos x. Okay, so in this case here, the cos x's are going to cancel out, and we're going to be able to combine our sine x terms. We're going to end up with 2 groups of 2, so 4, and it's going to be negative e to the x sine x. Okay, so this is 4e to the x sine x. When we plug in 0, we're going to end up with 0, so that coefficient is going to be 0. And then our last derivative, we're going to end up with negative 4 e to the x, and this is going to be cos x plus the derivative, sorry, it's going to be sine x, and then we're going to differentiate, we're not going to differentiate e to the x, and we're going to differentiate sine x, so we're going to get cos x. So when we evaluate this at 0, so negative 4 e to the x, and then times sine x plus cos x. This is going to be equal to, cos x is equal to 1, so we're going to end up with a coefficient of negative 4 over 5 factorial. And this works out to be negative 4 over 120. We can simplify that to negative 1 over 30. Okay, so we've generated our derivatives. We've calculated our an terms. Now we can construct a Taylor series based on this. So our Taylor series, in this case, we're going to write our 5th degree Taylor series for this. It's going to be equal to 0 plus 1x plus 1x squared plus 1 over 3 x cubed, and then we're going to end up with plus 0 again, plus, this works out to be, it's minus 1 over 30 x to the power of 5. So that represents our 5th degree Taylor expansion based on these coefficients that we've calculated from our derivatives. Okay, so I'm just going to maybe get rid of some of those terms. So this becomes x plus x squared plus x cubed over 3 minus x to the power of 5 over 30. So that is our Taylor expansion, Taylor series for this complex function e to the x sine x. So we could calculate, try this out. We can calculate, in this case here, we're going to use the 5th degree Taylor polynomial to calculate e to the 0.1 sine to the 0.1. So we're going to plug in 0.1. So we're going to say that e to the 0.1 sine of 0.1 is going to be approximately equal to our Taylor polynomial when x is 0.1. When we work this out, we're going to end up with 0.1 plus 0.1 squared. Take that, put that in some space where I can work. Plus, the next term of that is going to be 0.1 cubed over 3 minus 0.1 to the power of 5 over 30. Okay, so working that out, plugging that all into my calculator, I'm going to end up with 0.1 plus 0.1 cubed, sorry, 0.1 squared plus 0.1 cubed divided by 3 minus 0.1 to the power of 5 divided by 30, and I'm going to end up with 0.110333. Okay, and what I can compare that to the actual value of e, so if this is from my calculator, the actual value of 0.1, e to the 0.1 sine of 0.1, my calculators give me a value of 0.1103. Okay, that's 0.3, I can give a couple more decimals here, 3.329. And you can see that this this is a fairly good approximation because we can see that up until this decimal place, even that's pretty close. We can see that that is fairly close approximation based on our fifth degree Taylor polynomial.